big deal here is that I do want to rewrite that right side because we have the ability to use our ln laws for derivatives. Makes life so much easier. Hello everybody, welcome to Cranky Calculus's logarithmic differentiation. Super important derivative we need to know how to master, so let's go ahead and go through that. Do not forget to like and subscribe for more content like this. So, a couple of formulas up here that you need to memorize for derivatives of log functions. It's highlighted right there. The derivative of ln of x is 1 over x. The derivative of, if you have a base b there, so log base b is going to be 1 over x ln of b. Using these formulas from above here, let's go ahead and differentiate, and a lot of these are going to turn into lots of chain rule. So for this first one, if we're going to differentiate y equals this ln function, I'm going to answer this as this is dy over dx is equal to, it's chain rule, so the derivative of the outside there, or sorry, the outside is just going to be 1 over this right here, times the derivative of the inside. So the derivative of the inside, it's just a bunch of power rule, is going to turn into 3x squared plus 4x. And then we can combine that together there to get 3x squared plus 4x all over our original argument within the log. And there we go. Next one here below that, let's go ahead and differentiate this one. Now we got to be careful that we're going to be using the log base one. So this one has a base 10. So again, if the log doesn't say anything, that is a base 10. So when I were to solve for this one, I'm going to go 1 over ln of 10, which is going to match what I have right now, times the derivative of the inside, which is going to be cosine of x. Sorry, not times the inside, not the derivative. Now let's take the derivative of this, and the derivative of cosine is going to be negative sine of x. So this is going to give me negative sine of x all over ln of 10 cosine x. Now, I can rewrite this a little bit because I do know that sine over cosine is tangent, so let's go ahead and rewrite this as tangent of x all over ln of 10. For our next problem here, it looks like that we have some quotient and some chain rule inside of the ln. Now, ln's can be a little special here, which is why we have the ability to use logarithmic differentiation, which I haven't really gone through yet. But we can break down our ln into multiple terms here. So instead of doing a big old quotient rule with a chain in it, we can actually rewrite this function as y equals ln of x cubed minus ln of square root of 1 plus x squared. It makes our life so much easier as we go through this. I can even use the logarithmic power rule and take that 3, throw it out in front. This is 3 ln of x minus, the square root really has a power of 1/2, so I can rewrite this as a 1/2 ln of 1 plus x squared. Now I can easily find these derivatives, so I'm going to get dy over dx is equal to 3 over x. Hopefully you found that as quickly as I did, minus 1/2 times, I'm going to get 1 plus x squared. If you don't mind, I'm going to do the derivative and just throw it in the numerator. The derivative of the inside there of 1 plus x squared is just 2x. A little bit of cleaning up here, those 2's cancel out, and I'm going to get this to be 3 over x minus x over 1 plus x squared. I usually get asked this, do you need to combine these fractions? You don't need to. You can just leave it exactly how it is. We are going to move on here to the logarithmic differentiation section of this, which is when we use ln's and we can take apart our derivatives. And we only want to do this when we're directed to. We don't ever just want to, on our own, do our own logarithmic differentiation. Because of the conversion of the domain, we do not want to do that. So for these two examples, we're specifically using logarithmic differentiation because that is what the example says to do. So what we're going to do here, I have the steps right above. You're going to take the natural log of both sides. That way you can pick apart each side, and then we're going to differentiate implicitly. So here we go. So for this one right here, the first step I'm going to do is take the ln of both sides. And this is going to enable me to pick this apart a bit and make this a little bit easier to differentiate. So I'm going to leave that left side alone as I go through here. The big deal here is that I do want to rewrite that right side because we have the ability to use our ln laws for derivatives. Makes life so much easier. So this is going to be ln of x to the 2/3 minus ln square root x squared minus 3x. I'm going to continue to rewrite that left-hand side. I'm going to use that logarithmic power rule to my advantage here to make these derivatives much easier. So now I'm going to take the derivative of everything, and this is going to be implicit, so I'm going to get 1 over y, tag it dy dx equals, it's going to turn into 2 over 3x, because I'm just going to get 2/3 times 1 over x, so let's just rewrite that, minus, and then this bottom here is going to be 2 times x squared minus 3x. The derivative at the top here is going to be 2x minus 3. And now all I'm going to do is multiply both sides by y. So I'm going to take this, multiply this by y, and if you do not mind, you better not mind, I'm going to just copy down my y value as I rewrite this. So this final answer is going to be 2 over 3x minus 2x minus 3 all over 2, you don't need to expand, you don't need to distribute this at all, times y, which is, and I do have it above there, I'll zoom out so you can all see that, times x to the 2/3 all over square root of x squared minus 3x. All right, so that problem could have been a huge bear. I could have had to do a bunch of chains inside quotient rules. I think this makes it a little bit easier for us to do. Now let's go ahead and move on to this last problem, though. This is a fun one. So using logarithmic differentiation, and we have to this time. There is no option because there is no derivative we can do here. So we will rewrite this as ln of y equals ln of x to the power x. So just kind of keeping that left side with it. I'm going to use the ln power rule, and then I can get here. And this actually becomes a little bit easier now. So I'm going to get some product rule on the right-hand side. So left side, I have my 1 over y. Oh, why am I writing ln? 1 over y times dy dx equals product rule. The derivative of the first is going to be 1 over 2 root x. Please memorize that derivative. Derivative of root x is 1 over 2 root x. Makes your life so much easier. Plus root x times derivative of ln of x is just 1 over x. Some minor cleaning up here just to make it look nicer. Before I multiply that y on both sides, I'm going to get ln of x over 2 root x, and then plus, this actually ends up being 1 over root x. In case you didn't know that, because you get root x divided by x, take the exponents, subtract them, you're going to get x to the negative 1/2, so that's why it's root x on the bottom. Now I'm going to multiply both sides by y, and I will actually write down the final answer as it comes. So dy dx equals this ln of x all over 2 root x. Actually, I'm going to have to zoom in here to fit this thing in here. Plus 1 over root x times y, which was my x to the root x. Wow, what an ugly answer that is, but hey, that's what we got to do here. That is going to wrap up our video here. Do not forget to like and subscribe.